Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. In this video, I will continue making house price prediction model. Let's continue. So MSE. So what it will do is this makes sure that large errors, big differences between actual and predicted values are given more weight than smaller errors. So let's see the real world example. You will understand it better. If your model is predicting house prices and one house was actually 50 lakh, but your model predicted 60 lakh, the squared error for that house will be 60 minus 50. So 60 predicted minus actual, and then what we will get after this 10. So 10 squared will be 100. So what will happen is large errors like predicting 1 crore when the actual price was 50 lakh. So actual price was 50 lakh and our model is predicting that the price our model is predicting that price is 1 crore. Then this will result in much higher squared error like this. Now how to check and the metrics this MSE? Lower MSE is better. It means your model's prediction are closer to the actual values. So what you will be looking at, it should be lower it should contain lower value, not higher. Low value. Lower the value, better will be the result. If you see in the example prediction, predicted price and actual price this. So if these two prices are contains huge difference, then your model is not working fine. You have to add more things or rectify the things. So this is how you look for MSE. Lower MSE is better, and this is how you calculate it. This is the simple formula. You will understand this from easily from this name also. So this name is squared error. This is what squaring is all about. Okay, so let's see r squared. What r squared is, let's see here. Okay, so we are having these values r squared here. Let's see. R squared measures how well your model's prediction match the actual data. It measures how well your model's predictions match with the actual data. It tells you what percentage of the variation in the target variable can be explained by your model. Let's move to just real world example. If your R square is 0.80, that means your model explains 80% of the variance in house prices, and the remaining 20% is due to other factors or noise that your model couldn't capture. How to check this matrix? Higher R2 is better. It indicates your model is doing a good job of predicting the target. So what you will look at is, so higher R2 is better. Let's see higher R2. So 0.82, how you will say? It explain 82% of the variance in the house prices. So higher R2 is better. So you can change the algorithms, add new things to this code and check if these metrics change. So you will understand that if, you can even create a better model than this that I have created by applying more techniques and check these metrics, and if they are better than this model, then your model will be better than mine. This is how you check and create models in real world. Mean absolute error, MAE, is similar to MSE, but instead of squaring the errors, it takes the absolute difference between the predicted and actual values. Let's see the real world example. If your model predicted 60 lakhs but the actual price was 50 lakh, absolute error is 60 minus 50, but this time we are not squaring the error. What we are doing is just ignoring plus or minus. This is what you call these things. We are just ignoring the plus and minus. So if for example this was uh, less and this was more, so what you will be getting is in negative, and this will change this value, but we want the final answer. What we need the final answer in the positive manner or in a plus. Then what we can do is just this is how MAE works. So what you will do is again just subtract the model predicted price with the actual price and give the answer in positive. That's what you need with MAE. MAE gives you an easy to understand number that shows the average error in your prediction. So just subtract the model prediction with the actual price and give the answer in positive. That is what MAE is. How to check this? Lower MAE is better. It means on average your model is predicting closer to the actual values. So lower. Let's see, MAE lower is better. Yeah, we are getting this here only. So lower is better. So you can check, you can train your model, apply multiple techniques, do multiple things, and if your MAE is less than mine, then your model will be better. Question, very important question: when to use MSE, R squared or MAE, when to use it. So you don't have to actually worry about these things, because these are just 1 or 2 line of code, and Python will automatically deal with all the things, machine learning things. You just have to know the concept, what you are trying to do, so that when you face this problem in real world, you can apply these techniques. This is what you are looking at. Just remember, these techniques are available and you can apply it on any project, and then your supervised learning project will run smoothly. MSE is useful if you want to penalize large errors more than small ones. So if you want to ignore the small errors and check out for large errors, because squaring the errors give more weight to larger mistake. So you want to go for large mistakes, then go for MSE. R squared is great if you want to know how well your model explains the overall variation in the data. Check out this word, overall. It is good for evaluating the goodness of fit of the model. So is it working fine? Go for R squared. If you have question, it is working fine. So for overall, go for R squared. MAE, simpler and gives you the average size of the error. Average size of the error in the same unit as the target variable. So it's easier to interpret when you want to know how far off your predictions are on average. So if you want to know how far off your predictions are on average, go for MAE, how far. Overall, large mistakes, remember these words. These are the use cases. Now you will ask me how to apply this. Just 3 line of code. Mean squared error like this, R2 underscore like this, mean absolute error like this. That's it. Now let's look into, so we are getting this from sklearn.metrics, all 3. Don't have to write much code, just these 3 lines of code will do it. Just pass the required arguments and it will do it. Nothing too complex. So this type of output you will be looking at from these three errors. And then the last code, what it will do is just you print this output, predicted price and actual price, like this. You will ask me what this dot 2f is. So the we are getting a huge number in the floating or decimal point. So this is 0.225456, huge. So what this will do is reduce it to 2 decimal point. Dot 2f will reduce it to 2 decimal or say floating point number. This is what it will do. Now the last one is outliers. What this means, so I haven't applied everything for outliers in this so that it can this project can be easy one. So I haven't applied the complete code, but given just the overview. If you want to apply it, it is up to you. Interquartile range IQR method, what we are using here is like this. That's it. What are these? Outliers are data points that are significantly different from the rest of your data. So you have huge data with lakhs of entries, but some data is completely different. Some specific data is completely different from rest of your data. They might be extremely high or extremely low values compared to the typical data point. So for example, if you see a normal range of homes like flats or something, so they go from like 30 lakh rupees to 1 crore rupees, like so most of the homes will be like this. But if you see the big homes or villas or some premium housing, then they will go to like 150 crore, 200 crore. So from this huge data that we will get in the form of data set, they will contain extremely high or extremely low values. So for example, some house is 1 lakh rupees only, so it will be extremely low value, and extremely high 150 crore. Okay, so this data will be termed as outliers. That specific data will be called outliers. What will happen if you have this kind of data in the data set compared to the typical data point, and they can impact your model's performance by skewing results, reducing accuracy and leading to overfitting. So these kind of problems will arise with outliers. How you can remove them, ignore them. So I have written the code, but I will not go into too much detail for this code, because I haven't applied the complete this thing here. I have just given some code here. If you want to ignore, you can ignore this code. You can completely ignore. And in the output you can see number of detected outliers, because we don't have any outliers in our data set. We don't have this problem. So this is the reason I have not applied it in our code, because we don't have any outliers. If you have the outliers, then you can look for the solution how to rectify it. I will show you in future session if we run into this problem, but for now we don't have this problem with this model. So this is the reason I have not applied it. This is the complete code for this project. I have explained it step by step everything, and recorded videos will be available soon. This marks the completion of this project. I will see you in next session. Have a nice day.